Assalamualaikum. Today we will present our lab assignment using MAPL, focusing on weekly dengue cases analysis in Hulu Langat for the year 2025. So this is our group member. Myself is Muhammad Aziz Afif bin Huzari, my friend Muhammad Hasdi bin Zainan, and No Ikmal Shazlan bin No Suhailan. In Malaysia, dengue fever remains a serious public health problem, especially in densely populated area like Hulu Langat. For this project, we use officially weekly dengue case data from the Selangor State Health Department JKNS. The main purpose of our analysis is to observe weekly change in reported dengue cases, identify pattern or trend, apply mathematical and statistical technique, specifically a quantitative model, to understand how dengue case progress over time. Here is the data contain the number of dengue cases from week 1 to week 10. For the implementation in MAPL, we use the quadratic model. First, we define M as the week number. As a column vector, M is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Second, we define FM as the number of dengue cases, which is FM equal to 66, 99, 100, 84, 73, 90, 86, 79, 77, 88. And lastly, we define A1 as the coefficient of constant, which is A1 equal to 1 for every single row in the column A1. And we can say A equal to A1 bracket M bracket M tilde M. AY equal to A bracket FM. After that, we can use reduced row echelon form for AY.
Hello everyone and good day. I am Nur Ikmal Shazlan and my matrix number is 2025 419494, and I will be explaining on how to obtain a least square solution using MAPL and also manual calculation. To obtain a least square solution in MAPL, we must first classify the transpose A as AT, and the result will have 1 1 1 1 1 1 1 1 1 1 1 1 2 3 4 5 6 7 8 9 10 1 4 9 16 25 36 49 64 81 and 100. Next step, we have to multiply the transpose matrix with the normal matrix A. So we classify that as ATA. The result should be 10, 55, 385, 55, 385, 3025, 385, 3025, and lastly 25,333. Then we shall multiply the transpose matrix A with FM, which is the number of dengue cases reported, and we classify this as ATB. So the result, we should get 842, 4,612, and lastly 32,078. Next up, we shall implement these two matrices, which is ATA with ATB. Now, the reason we implement this is because we are doing this in MAPL, and we shall obtain the result as 1055, 385, 842, 55, 385, 3025, 4,612, 385, 3,025, 25,333, and lastly 32,078.
Next, we move on to the implementation using manual calculations. Since we have 10 equations but only 3 unknown coefficients A, B, and C, the system is overdetermined. We cannot solve it directly for a perfect fit, which is why we must use the method of least square to find the best fit value for A, B, and C. To solve this overdetermined system using least square, we convert it into the matrix form AX equal to B, which is shown in the handwritten. B is the vector of dengue cases. It contains the 10 observed FM value from 66 down to 88. 8 is our coefficient matrix. It represents the value multiplying A, B, and C in our 10 equation. The first column is all 1. This is because A is constant. The second column is M, the weak number, 1, 2, 3 until 10. The third column is M to the power of 2. The weak number square, 149 until 100. This matrix A and the vector B are essential input for the normal equation A to the power of T AX equal to A to the power of T AB.
Next up is to multiply the transpose matrix with Fm, which is the dengue cases reported, and as previously, the transpose matrix would be in a horizontal form, and the Fm, or our Fx, shall be in a vertical form. So when we multiply them, we shall obtain the same exact results as we have in Maple.
So, as we can see, this is implementation step for maple calculation, and this is implementation step for manual calculation. First, we need to solve the system of linear equations derived from the least square setup before. This is typically achieved by working with an augmented matrix, which we call it SM. We use reduced row echelon form command. This is a crucial step as it solves the linear system with the equation A transpose AC and is equal to A transpose B, which is we identify C as a V and B as a FM in the maple. To verify our maple result, we also solve the system manually using Gaussian elimination. We begin by constructing the augmented matrix that represent this equation. Each step of the row reduction process, like scaling rows and eliminating variables like this, and we will get the answer from this. So this equation now is represent our best fit curve for the data, and this is B. Then we need to make Maple generates the graph of the quadratic best fit curve. This visual output helps us clearly see the relationship between the weak number and dengue cases based on the model. Next, to determine how good this fit is, we need to calculate the error vector. So the formula of error vector is E is equal to B minus AC, which is we identify B as FM and C as V in the maple. So this is how it is look like in the maple, and this is the answer of error vector. And if we need a single number to quantify the overall quality of the fit, we need to use the magnitude of the error. So the formula of magnitude of the error is, after we get the answer of error vector, for all of each this number, we need to square it and total all of it, and after that we need to square root it, and we will get the magnitude of the error. So this is the answer of the magnitude of the error, same as manual calculation. So that's all.